Okay, welcome. Tony Mormino here with the Engineers HVAC Podcast. So, in this episode, I'm going to quickly discuss the differences between on-off reheat and modulating reheat. So, we did a post on this the other day on LinkedIn, and it got tons of engagement, and it was great to see all the different comments and concerns with either. And then we discussed, well, what type of reheat are we talking about? Are we talking about hot gas reheat, electric gas? Anyway, I'm going to get into that and I'm going to explain, first of all, what reheat is, why we use it, and then the differences between modulating and on off, which is pretty darn important, especially if you're talking about tight tolerances of temperature and humidity control. So before we get into that, I want to first of all thank everybody who attended our live PDH event yesterday on LinkedIn. It was a record attendance. I think we had over 500 people join for various lengths of the episode. It was part two of a three-part psychometric PDH series we've been doing. So we super want to thank, we're super grateful is what I'm trying to say for everybody who joined us. It was tons of fun for us here at Insight Partners, Hobbs and Associates, Climate New Jersey, Climate New York, EBS, and ETS. And those were all the firms that were involved in putting that together. You can go watch that show now and the other PDH events we've done over the years on our YouTube channel, which is at HVAC TV on YouTube. So thank you so much, and stay tuned for part three of that. Okay, now getting back to the subject of modulating reheat versus on-off reheat. One of my favorite topics because I have a lot of experience with this, and it's pretty easy to explain and pretty important if you're in either, if you're a contractor or an engineer or even a sales rep. So before we talk about reheat, um, let me see. Let's think about how to start this. So I was going to start with the refrigeration cycle, but there are different forms of reheat. So let me start with the application itself, right? So reheat, there's a misconception that reheat dehumidifies the air. Actually, it does not dehumidify the air. It just heats the air. And if you were to look at this on the psychometric chart, you would see we basically move from the left of the chart, a lower temperature, to the right of the chart, a higher temperature in a horizontal line. So that's why we call it reheat. It only heats the air. It does not add or remove any humidity to the air. So first thing to talk about there. The second thing is, why do we do reheat? Okay, why do we do reheat in the first place? So here's how I explain it. Consider you've designed this system for, we'll say, 50 degrees leaving air temperature on a design day, which happens very infrequently, right? So it's middle of summer, 95, 78 outside, you got 50-degree air blowing off your packaged rooftop unit into your space. Everybody's happy because it's hot as heck outside and everybody's hot and sweaty and there's a major heat load on the building, etc. So that's fine and dandy. Now, what happens at part load? Okay, what happens on that same unit if it's October and cloudy and you are putting 50-degree air in the space? Well, you're probably going to overcool the space. It's going to get too cold in there. So your options, if you're a packaged rooftop unit, right, and you have a couple compressors, is to turn the compressors off, to cycle them off because it's getting too cold, or to elevate the leaving air temperature if it's a chill water unit, etc. You could even elevate the leaving air temperature if it's a packaged DX unit if you have a modulating compressor. That might be fine too. What happens if that unit has 30% outside air or 50% outdoor air and it's really humid outside? You start elevating the leaving air temperature. Now you're getting into trouble. Now you're pumping a lot of humidity in the space and you get a very cool and humid space. So to properly dehumidify, you have to get that air down to saturation. 50 degrees is a good point to get that down to. So what happens is we want to dry out the air by getting it down to 50 degrees. Then we want to reheat it back up so that it's comfortable in the space, right? It's very simple. So how do you know where to reheat the air? That's the other question. Well, if you have a control system, and let's say it's 72 is the set point in the space, it starts dropping 71, 70, your leaving air temperature is 50. Maybe you start increasing that by 5 degrees. Maybe now it's leaving at 55. Now it's leaving at 60. And you could see how you can iterate and see where the balance point is. And that's where the discussion of modulating versus on-off reheat comes in. Because if you have on-off reheat, you only have no reheat or a lot of heat. And you can get a lot of reheat out of some systems. So it depends on the circuitry and the loading and the time of day, et cetera. So if you have on-off reheat, and I've experienced this before, you're either going to get that 50 degrees or you're going to get 80 degrees, 70 degrees, 75 degrees. It's kind of, you don't really know. It depends on the state of the refrigeration system. So is that a problem? Probably. If you're trying to control tight humidity in the space and temperature, that could be a major problem. Some facilities where there's 20, 25% outdoor air and you've got a part load condition where there's not a lot of people there, it's probably not an issue. Okay, so just be careful of that. So with modulating reheat, you could actually nail the leaving air temperature you need. So you're continuously dehumidifying the air, then you're reheating it back up based on the sensible requirements of the space. Okay, so you can have 51 degrees, 52 degrees, 53 degrees, 54 degrees, leaving that unit. It's dry, we've dehumidified it, and we've reheated the air. Okay, great. So that's the difference. Now, I can tell you when I started in this business about 25 years ago, modulating reheat was fairly expensive if it was modulating hot gas reheat. Okay, today I would say most typical legitimate DX dehumidification unit manufacturers provide modulating reheat. Some of them don't even do on off anymore. Okay, and some of the products we rep are only providing modulating reheat. Okay, so that's a little bit about the application. We've talked a little bit about why we reheat, the myth that reheat dehumidifies the air, which it does not. Okay. So let's talk about different types of reheat. So we did a post on LinkedIn, and the title of the post was something like, let me read it here. On-off reheat is for sissies, real men use modulating, right? So it was meant to be kind of a joke, and there was a sign in front of me on a chair saying, prove me wrong. Okay, so we got a lot of comments on that based on, turn this light back on. Here we go. We got a lot of comments on that, like, hey, what about SCR heat? SCR reheat works well. So if you're not familiar with SCR heat, SCR is what's called a pulse width modulation method. So it is a controller that brings the heater on and turns it off real fast. And what that does is it gives you control of the leaving air temperature down to the, tenth of a degree. It's super accurate modulating heat control. Now, the question really is, can you use electric heat for reheat? And I think in some very limited applications, hospitals, labs, you can still do that. But I'm pretty sure the energy code does not allow for electric reheat in the vast majority of applications. Electric reheat or new energy reheat, okay, which would be like gas reheat, or you have a boiler that's gas driven and you're using the hot water for reheat. So new energy reheat, I believe, is outlawed in most cases by the energy code. Someone correct me if I'm wrong. Comment on this podcast or video if you can. Share that information. But so SCR does work well for reheat. It works extremely well for modulating reheat. Is it allowed by code? That's something you have to check into. Then and I got another comment here about using gas for reheat. Modulating gas can do a great job of controlling reheat. Two of the things to look for in that is, does code allow for that, as we just discussed? The other issue is modulating gas burners typically have a turn down ratio. Okay, you don't have this in SCR electric heat, and you don't have it, as far as I know, in modulating hot gas reheat in any product I've done. Modulating gas heat, let's say you have a gas heater with a 3-to-1 turn down, you can only go down to 30% of the capacity of that heater. Is that too much heat? Don't know. If you're doing a surgery suite or something where very precise control is required, be super careful of that, because you are going to have that minimum and it might kick you up 5 to 10 degrees each time. That might be too much and you might be chasing your tail. So just be super careful with that, but modulate, or get a burner that has a 5-to-1 turn down, or what I've seen in the past is a combination of SCR electric reheat for the really low load conditions, and then a modulating gas heat for the when you need more reheat. Of course, that adds some complexity to it, which I like to keep things simple. So don't do that unless you need to. And then I got a bunch of comments here. I'm just looking about, how modulating is way better with control and things along those lines, which we just talked about. So that's the podcast for today. I hope you enjoyed this. I like these little quick 10-minute topical podcast where I get to talk about what's hot this week. So this post was hot this week, so I wanted to talk about that. And again, I wanted to thank everybody for attending our live podcast yesterday. It was so much fun. If you go to YouTube and look up our videos from 9/12/2024, that would be September 12th, 2024, which was yesterday during the recording of this podcast, you can see the video there on psychometrics. And, you know, if you want to follow us, you can go to my LinkedIn page. It's Tony Mormino, and you could see the notes in this description here, or follow us at Insight Partners on LinkedIn. We do all of our announcements there for our live podcasts. So thank you so much for listening, and I hope you got something out of this show. Thank you.